All right, guys, we are on day 2 notes of Unit 10, and we're going to create equations of polynomials from the picture of them. So the other day we created the equations of polynomials based on their roots. And so now they're not telling us the roots, but they're giving us a picture of the roots inside our graph. Okay, and so we'll pull those roots out of the picture, and then we'll be able to do the same exact thing we were doing on the end of day 1. So in the little blurb above, it says if the zeros of a function are known, a possible equation for that function can be written. Be careful for functions that have double roots where the graph is tangent to the x-axis, which means the graph just touches the x-axis at one point. However, at that one point, there are actually 2 roots called a double root there. When the functions are graphed below, create a possible polynomial equation in both factored form and standard form. Okay. We also have to be careful about the leading coefficient. And if we know that the leading coefficient, based on how the graph is graphed, if that leading coefficient is negative, we have to remember to put a negative in our factored form, and thus we'll distribute it in order to get the standard form. Okay. All right, guys, here we go. Taking a look at number 1. That is a quadratic, and it has 2 roots, and we can see the 2 roots from our graph. All right, so one of the roots is at x equals -2, and our other root is right at the origin, so x equals 0. All right. Next thing we have to realize is that this graph here has a negative leading coefficient. Okay, and now we'll put that all together and write it in factored form. And so we're going to have our solution of x equals -2 turn into a factor of x plus 2. X equaling 0 will just become a factor of x. Okay, and then we need the negative as our negative leading coefficient. And don't forget, we're writing equations, so these should be all equal to 0 or y. All right. And now we'll go ahead and say that that is our factored form. However, we're going to put it together to get our standard form. So the very first thing I'm going to do is I'm going to put these 2 factors back together. So I'm going to leave the negative here for a second. And when I put these back together, that's going to end up being an x squared plus 2x equals 0. And now I'm going to insert the negative by distributing. And so we end up with a negative x squared minus 2x equaling 0, and that is one possible equation for this graph. It has the correct zeros, and it has the correct leading coefficient sign, and so this one is finished. Okay. Let's go ahead and take a look at number 2. Okay. So in number 2, that is what they call a cubic. It has 3 roots. Okay. One of the roots is at -1, so we'll say x equals -1. One of our roots is right at the origin, so we will say x equals 0, and our last root is at x equals +1. Okay, and so now we're going to go ahead and turn those roots or solutions into factors. All right, so the x equals -1 used to be an x plus 1. X equaling 0 is just an x, and I think you saw in the last one that it's almost easier to put that out in front as the first factor. Okay, and then x equaling 1 will turn into a factor of x minus 1. And don't forget your equal 0 so that it's an equation, okay? And so there's your equation in factored form. And now we're going to go ahead and put it together, all right? And again, if you want a little box to put it together, you can, all right? I'm going to actually put these 2 together first, okay? So my 2 binomials, we got x plus 1 and x minus 1. And so that's going to be x squared plus x minus 1, okay? So my x here will stay for now, and those 2 binomials produced x squared. These 2 terms are actually opposites of each other. If you notice, those 2 factors are conjugates of each other, which is why they cancel. Okay? And then -1 equals 0. And now we're going to go ahead and distribute that x in, and so that's going to give us x cubed minus x equals 0. All right, and this one is finished, okay? In this one, notice, guys, we have a positive leading coefficient, and I didn't have to put a negative in because the whole reason, guys, is that it ends going up, all right? The right side is going up, and that is a positive leading coefficient, which I forgot to talk about, all right? Okay. And that one is done, so let's take a look at number 3. Okay. In number 3, what we have to watch out for is right here. That is what they call the graph being tangent to the x-axis. It just touches it. And right here, guys, is going to be a double root. So we know that there is x equals -3 happening twice. Okay, and then down here, goes through the x-axis again, and that's x equals 5. All right, so this is a cubic again, and we're going to take those 3 roots and turn them into factors. And so we're going to end up with x plus 3, x plus 3, and x minus 5, and we're equal to 0. And the one thing we didn't talk about is the leading coefficient. And if you look at the right end, that ends going down. All right, and this would be a negative leading coefficient. And so we are going to need to add a negative out in front of our factors. Okay? And that's the equation in factored form. And now we're going to go ahead and put it together. Okay. What I usually do is I think I would most likely put these two together first, possibly in a box, okay, where we have x plus 3 and x plus 3. Okay. Filling in the box here, we got x squared plus 3x plus 3x plus 9. And those two plus 3x's will go together. And so in our equation, we have a negative still. We have the x minus 5 that we haven't used yet. And those two x plus 3's being multiplied together give us an x squared plus 6x plus 9 equal to 0. All right, so you'll notice, guys, I rearranged my equation a little bit, but that's okay because there's multiplication between everything, and so multiplication can be rearranged or have the order changed. That's called your commutative property. Okay. All right, so what I might do next is to make things a little bit easier. Actually, it doesn't really matter. Like I said, you can do the order of anything because it's all being multiplied together. So you might leave that negative there, or you could put the negative in with the x minus 5. All right, it's up to you. We'll leave the negative there. All right, so what I'm going to do now is I'm going to go ahead and multiply those two together. So I'm going to need a little bit of a bigger box. I need a 2 by 3. All right, and I'm going to have the x minus 5 along the side and the x squared plus 6x plus 9 across the top. And then I'm going to fill it in to get an x cubed plus 6x squared plus 9x minus 5x squared minus 30x minus 45. All right, and so putting that back in, I'm going to have an x cubed term. I have a 6x squared minus 5x squared, which is a plus x squared. I have a 9x minus 30x, which is a negative 21x. And then I have a minus 45, and we are still equal to 0. And now I'm going to go ahead and distribute the negative. So I have that negative leading coefficient. So my graph will end negatively or going down. And so we end up with negative x cubed minus x squared plus 21x plus 45 equal to 0. And there is my equation of this possible polynomial that has those roots, a double root at negative 3 and a single root at 5, and will end negatively because it has a negative leading coefficient. All right, hopefully that's making sense. And we have one last one to do on this side. Okay, so taking a look at what our roots are, it looks like we have one root at negative 3. We have a double root because that is tangent to the x-axis here. So this is a double root. So not only will we have one x equals 0, we will have a second x equals 0. Okay, and then we have a fourth root down here at x equals positive 3. Okay. Talking about the leading coefficient, because this ends going up, our leading coefficient will be positive, and therefore we won't have to worry about it. Okay. All right, here we go, guys. X equals negative 3 will turn into an x plus 3. X equaling 0 will be a factor of x, which I think we've realized it goes out in front, but we have another one, so we'll have another x there. And then x equaling 3 being our last root will turn into a factor of x minus 3. And don't forget, equals 0. And we don't need a negative out in front because this is a positive leading coefficient because the graph ends positively going up. All right, here we go. So what we could do, guys, here to make it a little bit easier is not only put those two together, but also put those two together. Okay, and so if you need a little box there to put them together, go ahead. You got an x plus 3 times an x minus 3 to give us x squared plus 3x minus 3x minus 9. And we'll go ahead and put those two middle ones together. So we end up with x squared The 3x and the minus 3x actually cancel, and then a minus 9. Don't forget equals 0. All right, and then we have one last step is to put the x squared multiplied in, and so we end up with an x to the 4th minus 9x squared equals 0, and there is the equation that is possible for this picture that we were given. All right, I will see you guys on the back side of notes for a little bit more.